All right, 2.6b, continuing on here discussing piecewise defined functions. Yesterday we learned that a piecewise function is essentially a function made up of two or more pieces. Those pieces can be rays or they can be segments. We also did the problem two ways. One, we were given the equations. Okay, often it looked like this, where there was an equation and then a domain restriction, and we would create the graph. And then we were also given the graphs, and we were working backwards to kind of build the equations and build what the domain pieces were. What we're asked to do here on these first two examples, we are given the graphs. We're not asked to come up with the equations. We're just asked to examine this graph and simply state what we think the domain and the range would be for each of these two graphs. Okay, so what you want to keep in mind when you're doing this is that the domain, those are the x values, the range, those are the y values. So when we're thinking x values for domain, you want to be thinking of the x-axis, which spans from left to right. You want to locate the point on your graph that is farthest to the left. If that is an arrow that continues on forever, that means your domain, the smallest x value, would be negative infinity, which is the case for this particular graph. Okay, once you've identified that leftmost x value, which again is negative infinity, you would want to imagine traveling from left to right on that piece until that piece stops. You'd want to pay attention to what the x value is. On this particular graph, it's a 1. And then you'd want to look at the other piece and see if that piece picks up at the exact same x value where the other piece left off. And in this case, this one stops at an x value of 1, but this one picks up at an x value of 1. And then as we travel from left to right, the x values continue on to positive infinity. So these two pieces connect to each other from the x values. So we would say the domain is all real numbers. You could either say from negative infinity to positive infinity, or you could use that symbol for all real numbers. Okay, now let's do the same thing with the range. We know range are the y values. You want to think of the y-axis that goes from the bottom to the top. You want to start with the lowest y value. Since there's an arrow pointing down, the lowest y value would be negative infinity. We would want to travel from the bottom to the top of this piece, stopping where the top part of that piece is and asking ourselves, what is the y value of the top piece there? That y value is a 1. Now we would want to say, does the next piece pick up at the same y value where this piece left off? Well, this piece went from negative infinity to 1. This piece up here isn't starting until it gets to a y value of 3. See, there's a little vertical gap there. Since there's a complete disconnect vertically, I'm going to have two separate sections to our range. The first piece goes from negative infinity to a y value of 1. And it does not include the 1. See how there's a hole there? So I'm putting a parentheses. The other piece starts at a y value of 3. Notice it's closed here at 3, so I'm choosing a bracket. And then it carries the y values all the way up to infinity. Okay? All right, let's try the same thing here on this graph. Domain, we're going to start with the x's, okay, from left to right. This is the leftmost piece. It goes to the left forever. That's going from negative infinity to this piece is stopping here at an x value of 1. Now, this next piece is not starting until it is at, I think this is a little bit messed up because I've got these markings here in black and then the grid says something different. So I apologize for that. Let's look at the grid and not these markings I have here. Okay, I'm going to go ahead and just kind of wipe those markings out a little bit because I think that's a little deceiving here. Okay, so it looks like we said this piece ends at an x value of 1, but this piece here isn't starting until we get to an x value of 4. So there's a gap now horizontally This is not picking up where that one left off. So I'm going to have two parts to this domain. It's going to go from negative infinity to an x value of 1, not including 1. And then this next piece is going to pick up at an x value of 4 and then carry the x values as I move from left to right to positive infinity. Okay. My range, I want to start, look at the y's, start with the lowest point. Okay, this would start way down because there's an arrow here. At negative infinity, I would travel up that piece until I get to where it stops. This y value looks like it's 1, 2, 3, 4, 5. Looks like it's 6 if I'm counting on the grid. Okay, so this goes from negative infinity to 6. Look at where this piece starts. It picks up at a y value of 6 if you're counting on the grid here. And then it carries the y values as I travel up to positive infinity. So here, these two pieces are connected vertically. So I could say that the range is from negative infinity to positive infinity, or I could say all real numbers. Okay. All right, let's try one where we're actually graphing this. If you remember yesterday, how many ever pieces there are, you're going to make an XY table for each piece. Okay, each row represents a piece. There are 3 rows to this problem, so I'm going to have 3 XY tables. Recall this f of x represents your y equals 3, y equals 4x minus 3, and y equals f of x. And we write those equations at the top of each of our tables. Okay, this is how you set up these problems. Okay, now let's start with the first piece, the first row. We're going to take our x value that we're given, and we're going to plug that x value in for any x's in our equation. Now look closely. There aren't actually any x's in this equation. That means there is no place for us to substitute this -1. In fact, no matter what number x is, since there's no place to plug that in for an x, the y value continues to be a -3 that gets spit back out, okay? So -3 is what I'm getting, okay? If you recall, we look at the inequality symbol to determine whether this point should be closed or open. If there is no inequality symbol, if there's no equal to bar underneath the inequality symbol, that is when we say this point is open, okay? Also, if you remember, if there is only one number as opposed to 2, then that section represents a ray. So this is going to be a ray, a segment, followed by another ray. Okay? Because we have one number, 2 numbers, 1 number. Okay? Now, we do need a second x value. Okay? But if I'm not provided one, then I get to pick one. But I need to look at my inequality symbol when I'm choosing what x value to go with here, okay? So I need to choose any number as long as it is smaller or less than -1. So I'm going to choose -2. Again, there is no place for me to plug -2 into my equation, so it still returns the number -3. I'm going to go ahead and plot an open point at -1, -3, and then I will plot a closed point at -2, -3, and I will draw my ray through that -2, -3 point and continue going past that with an arrow. Okay, let's go ahead and look at the second part here. Okay, the second part, I'm going to take my first number, -1. That will be my first x value. Here I actually do have an x to plug that in for, so I'm going to plug -1 right here for the x, and I'm going to simplify what number this would come out to. So it looks like that would come out to a -7 for the y. Okay, I'm going to look closely at my inequality symbol here. I notice that that particular symbol has an equal to bar underneath. So I'm going to make a note that this point -1, -7 should be closed. I'll go ahead and plot that. 1, 2, 3, 4, 5, 6, 7. I believe that would be right here, closed. Okay, then I'm going to take the other number, the 3. I'm going to go ahead and plug the 3 into my equation right here for the x. Okay, and I'm going to simplify that. Looks like we would get a 9 back out. I'm going to pay attention to whether there is an equal to bar. Underneath my symbol, there is an equal to bar, so that tells me that this point also should be closed. I'm going to plot the point 3, 9, 6, 7, 8, 9 up here. Remember, we said this one is a segment, so I'm going to go ahead and connect both of those. Okay. All right, my last one. I'm going to come down here. I'm going to take the one number that we are given. I'm going to use that as my initial x value. I plug 3 right in here for the x. It's going to spit back a 3. I'm going to take a look at my symbol and say there's no equal to bar, so that means this point 3, 3 should be open. Right there's open. Okay, remember we said this is array, so I'm looking at my symbol. It's a greater than symbol. I want to choose a number that is greater than 3. So any number will do, greater than 3. I'll pick 4. I'm going to go ahead and plug 4 in for the x. It's going to spit back a 4. Okay, all the other points on array are always closed. So I'm going to plot the point 4, 4, and then run my pencil starting at 3, 3 through the point 4, 4 and continue past that with an arrow. Okay, that would be the graph. This then also asks us to state the domain and to state the range. Okay, when I do the domain, I start all the way on the left. This goes to negative infinity, boom, 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 boom. It stops at an x value of -1, but look at my next piece. My next piece starts at that same x value, so these are connecting. Goes from -1 to 3, stops at 3, but look at where my next piece picks up at an x value of 3, so these are connected, and then it carries on to the right forever. So I can say the domain is all real numbers. I can say it either one of those two ways. Then I'm going to do the range. What is the lowest y value? Well, this point right here is the lowest y value. I believe that was a -9. Okay, as I travel up this graph, it stops up here. I'm sorry, not -9. I think it was -7. Okay, it stops up here at 9. But I don't think 9 is the very highest y value because I've got this arrow. Technically, this arrow keeps going way higher. Sorry, that was curved. Way higher than this value. It would carry on the y values up higher. Now, the y values are all constant. Every single point on this, the y values are -3. And I'm already kind of including that when this passes over where the -3 is. So my lowest y value is going to be -7, and then the highest y value, so it keeps going from here and then it kind of comes over here, keeps picking up, is positive infinity. Okay, all right, that completes this page. Although what I would like to do just real briefly, just to make sure everybody is comfortable, is I just want to take a quick look at example 5 from yesterday's notes page, because we only got to actually do one of those, and I just want to look at this very briefly with you at how to go from a graph to creating like the equations. Okay, so I'm gonna run through this one quickly so that you've just got another one that we've kind of chatted through. I would encourage you, how many ever pieces there are, I would encourage you to kind of set the problem up like this, so that we need a slope and a y-intercept for each of the 3 pieces, and then we only need the domain sections after the word if here. Okay, if you recall, we're going to label this first, second, third for our 3 pieces, and I want to identify the slope and the y-intercept for each piece. Now, if you look closely at this, to be a little bit careful here, this scale is counting by 2s, okay? So I'm just going to identify here a couple points, because this makes this a little tricky. I think that this end point of this ray looks like it would be -3, maybe -1, okay? Like going to the left 3 if each box is 2, and then down would be 1 if each box is 2, okay? And then I need another point so I can try to get the slope. It looks like maybe here it's crossing at -6, 0. Okay? If you're not comfortable counting up and over for rise over run, you can always identify 2 points like I just did. And then you can use the slope formula, y2 minus y1 over x2 minus x1, to calculate what your slope is. Okay? So I'm going to connect those. Looks like we're getting -1/3 for our slope. Okay, now we said yesterday the rule is if that piece is not physically touching the y-axis, then you need to use point slope form to get the y-intercept. Okay, this right here is point slope form. Okay, it requires you to pick a point and along with your slope and substitute that in. Okay, so I'm going to go ahead and pick that point negative 6, 0. Okay, 0 is the y. Oops. Our slope we said was negative 1/3. And then we're going to plug negative 6 in for the x1, and I'll connect those negatives and distribute. Okay, so it looks like I'm getting y equals negative 1/3 x minus 2. Okay, so I'm going to use this part right here and say negative 1/3 x minus 2. Okay, when it is a ray, you're going to put the x value, leave a gap here for your inequality symbol, write down the number where that ray's endpoint is. The ray's endpoint, the x value, is negative 3. And then when you're choosing which symbol to put here, look at which way the ray's pointing. This is going to the left, which is the direction that your x values go when they get less. Also, the endpoint of that ray was closed, so I'm going to put an equal to bar. Okay, let's move on to number 2. The second piece is a flat horizontal piece. Okay, if it's flat, we know the slope is 0. I can see in the picture that is crossing at y equals 2. I'm going to throw those together in the form y equals mx plus b, or you could just write y equals 2. We're going to fill in 2 here. Okay, this is a segment. Segments should always start out for the domain for you writing this, and then you're going to put the x value of where the segment starts and the x value of where it stops. This is starting at negative 3. It is stopping at an x value of positive 1. So negative 3, positive 1, those are both open, so I'm not going to put any equal to bars underneath there. Okay? All right, last piece. This one also is not touching the y-axis, so we're going to need to identify 2 points here, do our slope, and do another one of these point slope form here. Okay, looks like the end point of this last ray is at 1, 3. Here's another point, looks like that's maybe 2, 6. I'm going to take these 2 points, plug it into slope formula to get the slope first. Okay, my slope is 3. Then I'm going to use point slope form. Okay, I'm going to go ahead and use the point 1, 3. So I'm going to do y minus 3 equals my slope was 3. Times x minus 1. I'm going to go ahead and distribute. Add 3, add 3. Looks like I'm left with y equals 3x. So plug 3x there. This is a ray, so I'm going to put x. I want to fill in the x value of where this ray is ending, or starting, I guess, here. Looks like that's starting at an x value of 1. And then I want to look at what direction is this ray going. It's leaning to the right. So I'm going to choose a greater than symbol, and I will put an equal to bar underneath that because that ray was closed in. Okay, this right here would be the answer to all the equation and the domain pieces for this graph. Okay, hopefully that helps if you needed to see another example of that.